All hockey teams perform hockey practices or training sessions, so they often end up using many hockey pucks. Even if you're practicing by yourself, you know it's fun whenever you can dump all your pucks onto the ice at once, line them up in front of the net, and fire them non-stop. But at the end of practice, someone is left with having to bend down to pick up all the pucks by hand, which is a tedious task that no one wants to do, and one that could even cause injury. That is why for our capstone project, we are creating a robot that would roam around the ice, autonomously scan for pucks, diverge to pick them up, and then store them within the robot. We believe that our robot would save the user time and energy in their hockey practices and training sessions. My name is Jeffrey and I am the CEO of Project Bot Solutions. I was mainly in charge of the software on the Raspberry Pi that controlled the puck hoover, and I also handled the puck detection computer vision system. Tina was in charge of the frame design, assembly, electrical design, as well as the ice rink testing. Forbes was in charge of the electrical mechanical design and integration. Hannah was in charge of the frame design and picking up mechanism design. Edwin was in charge of the assembly and electrical design, as well as the ice rink testing. We have spent the past 3 months working on creating a proof of concept prototype for the puck hoover, and we worked through many CAD model iterations for its design. We received helpful feedback from the ENSC 405 instructional team and spent weeks implementing and testing the different designs for the puck hoover. To work on the puck hoover, we were able to get private access to a workshop almost once a week, and we were able to frequently work in Forbes' garage. We reached out to several ice rinks in the area and secured one that was willing to work with us. This ice rink access allowed us to perform weekly experiments with the ice rink to test the puck hoover on an ice surface. With the puck detection computer vision system, we have it working to a point where it is able to take an image from the sensor, apply a mask to simplify the image, and identify the locations of the blobs that are the hockey pucks. This is implemented using a Raspberry Pi, an image sensor, and OpenCV, which is a computer vision library for Python. The image on the left shows the original image from the image sensor, and the image on the right has the mask applied and the red circles around the blob, which the algorithm suspects are the hockey pucks. More work will be done to make this algorithm more robust and be able to better identify the pucks in the image. After getting all the subsystems to work independently, all that was left to do was to integrate all of them together for the proof of concept prototype. Here you can see the puck hoover moving on the ice using manual controls and the puck lifting mechanism lifting the hockey pucks into the puck hoover. These subsystems can be operated simultaneously and are controlled using the Raspberry Pi. The 2 back wheels are driven by 2 DC motors, one for each wheel, and the puck lifting roller is driven by 1 DC motor. To control the motors, we use 2 L298N motor controller modules to connect the motors to the Raspberry Pi. One module connects to the 2 driving motors, and the other module connects to the puck lifting roller. More work will need to be done to integrate the puck detection system into the proof of concept prototype, and implement the algorithm to autonomously move the puck hoover around the ice.